at the way that people measure it right at the moment. This is different. This is actually a different explanation for it. But I think this is most of the time what people are doing. Say that last part again. I think most of the time this is actually what people are seeing. Okay. And there's actually fairly good evidence that that happens reasonably often. Right? So you don't see the little crab that lives way back in the structure, right, until there's no fish able to eat them, and those crabs suddenly become more apparent, right? So as you get that disturbance.
So with your genes, the same genes that you see, you think that that's an energy efficiency thing by holding the same genes?
Yeah.
Because have you never thought about information theory? I would argue that you would get those genes because you've gone through the whole cycle of change and then you got back to that same point because that was the best way to be.
Yeah, so that never does that, right? So you would, the wobble would always give you a difference in the DNA sequence. So even if you ended up like going through all the substitution and through that whole space, you would never end up with the exact sequence. The more conventional explanation would be that they got, there's a much faster migration, right? A much faster recombination or something of that nature, which is that's kind of your alternate theories to this. You wouldn't be able to, I don't think you can hypothesize that you actually get evolution called reversions. You would get reversions that would allow you to have the exact same sequence. Seem reasonable? Yeah. In fact, there's massive, that's the substitution matrix that you use in your like when you're doing phylogenetics and stuff, basically assume that it's very unlikely to get a real reversion. I mean, you get them, but not a lot of them. So that's why you see convergent evolution instead of that's how you would get convergent evolution versus maintenance of things through time. Good? Okay, so let's quit now.